A pleasant day. We are the Group 8 and we are going to be presenting the third part of enterprise computing. It comprises of the three main topics, namely virtualization, cloud computing, and backup procedures. Using virtualization technology, you can run many operating system instances on a single physical computer or server, optimizing hardware resource consumption and enhancing the effectiveness of computer infrastructure management are the primary objectives of virtualization. The process of virtualization, which forms the basis of cloud computing, enables more effective use of physical computer hardware. Through the use of software, virtualization creates an abstraction layer over computer hardware, enabling the division of a single computer's hardware components, processors, memory, storage, and other components into several virtual computers, also known as virtual machines. Even though each virtual machine only uses a small percentage of the real underlying computer hardware, each one has its own operating system and functions similarly to an independent computer. The hypervisor allows the creation of virtual machines. They pool resources from the physical server and allocate them to virtual environments. There are two main types of hypervisors. The Type 1 or bare metal hypervisor, which is installed directly on top of the physical server. They're more secure and have a lower latency. The examples are VMware ESXi, Microsoft Hyper-V, and open source KVM. The other type is the Type 2 or hosted hypervisor. They have a host OS between the hypervisor and the physical server. These are less frequent and are typically used for end-user virtualization. Softwares like Oracle, VirtualBox, VMware Workstation are used in this type. Another type which is getting more popular and is branded as the future of virtualization is container. So a container, unlike Type 1 and 2, doesn't need a whole virtual machine to run an application. It is using lesser resources. One popular software for this is Docker. Virtualization has a lot of applications in the IT industry. It provides a sandbox environment for development and testing purposes. Developers can create and test applications in isolated virtual machines, allowing for easy replication of different environments without the need for physical hardware. Application virtualization allows for the encapsulation of applications and their dependencies, making it easier for deployment and management of software across different environments without conflicts.
Cloud computing is a technology that allows users to access and use computing resources such as servers, storage, databases, networking, software over the internet, often referred to as the cloud. Instead of owning and maintaining physical hardware and software, users can leverage these resources on a pay-as-you-go basis, scaling up or down as needed. These are the key characteristics of cloud computing. The first one is on-demand self-service. Users can provision and manage computing resources as needed without requiring human intervention from the service provider. The second one is broad network access. Cloud services are accessible over the internet from various devices such as laptops, smartphones, and tablets. Third one is resource pooling. Computing resources are pooled to serve multiple customers with different physical and virtual resources, dynamically assigned and reassigned based on demand. Rapid elasticity. Resources can be quickly scaled up or down to accommodate changes in demand, providing flexible and efficient services. The last one is measured service. Cloud computing resources are metered and users are billed based on their actual usage. Next, we have software as service. This delivers software applications over the internet on a subscription basis. Examples include Google Workspace, Microsoft 365, and Salesforce. Last one is function as a service. This allows developers to execute individual functions or pieces of code in response to events without managing the underlying server infrastructure. Examples include AWS Lambda and Azure Functions. Cloud computing has revolutionized the IT industry by providing cost-effective, scalable, and flexible solutions for businesses and individuals alike. Cloud computing is integrated into various aspects of our daily life, often without users realizing it. Here are examples of cloud computing being applied to our daily life: file storage and sharing, email services, social media, streaming services, and online collaboration tools. These examples showcase how cloud computing has become an integral part of our daily life, providing convenience, accessibility, and efficient services across various domains.
Grid computing is a distributed computing model that involves connecting and utilizing the computational power of multiple network computers to work on a task. It enables the sharing of resources such as processing power and storage across a network. Unlike traditional supercomputers, grid computing uses resources from diverse locations. The provision of cloud computing basics is frequently, but not always, linked to grid computing. Although the pros and cons of cloud computing are still being discussed, cloud computing jobs are hot and on the rise, and grid computing has come to the fore. So what is it? In grid computing, tasks are divided into smaller subtasks which are then distributed among the connected computers known as nodes. These nodes work concurrently to process their assigned subtasks, and the results are collected and combined to produce the final output. As a virtual supercomputer, grid computing is a network of connected computers to accomplish massive tasks like weather modeling or data analysis. Examples: CT at home. The Search for Extraterrestrial Intelligence project analyzes radio signals from space for signs of intelligent life. Second, folding at home. This project simulates protein folding to better understand diseases. Volunteers' computers contribute to the simulation, aiding scientific research in areas like Alzheimer's and various cancers. Last, the World Community Grid. It supports various research projects in areas like health, poverty, and sustainability. So, how to apply grid computing in IT industry? In the IT industry, grid computing can be applied to enhance efficiency, scalability, and resource utilization. Here are some ways to apply grid computing in the IT sector. First, distributed processing. Divide large computational tasks into smaller subtasks and distribute them across a grid of interconnected computers. This enables parallel processing, speeding up data analysis, simulations, and other resource-intensive tasks. Second, high-performance computing. Employ grid computing for high-performance computing applications such as simulations, rendering, or scientific computations. This allows organizations to handle complex computation by leveraging the combined power of multiple machines. Next, data processing and analytics. Grid computing can be used for distributed data processing and analytics. Tasks like big data processing, machine learning, and data mining can benefit from parallel processing across a grid, leading to faster results. Next, virtualization and cloud computing. Implement grid computing in virtualized environments and cloud computing platforms to dynamically allocate and scale computing resources based on demand. This enhances flexibility and resource utilization in cloud-based infrastructure. Next, fault tolerance and redundancy. Grid computing provides redundancy by distributing tasks across multiple nodes. This can enhance fault tolerance, ensuring that if one node fails, the overall system continues to function, reducing the risk of data or loss of system downtime. Next, rendering farms. In industries like animation, gaming, and multimedia, grid computing can be used to create rendering farms. This involves distributing rendering tasks for graphics and animations across a grid of computers, accelerating the rendering process. Next, collaborative research. Facilitate collaborative research by connecting geographically dispersed teams and allowing them to share computing resources. This is particularly beneficial for research projects that require significant computational power. Next, resource optimization. Grid computing helps optimize resources utilization by dynamically allocating tasks to available resources. This can result in a cost saving and improve overall system efficiency. By leveraging grid computing in these ways, the IT industry can enhance its computational capabilities, efficiently manage resources, and tackle complex tasks that require substantial processing power.
Backups on computers act as a kind of digital safety net. It is used to protect against data loss due to hardware failures, unintentional deletion, virus assaults, or system crashes. It entails making duplicates of your crucial files, apps, and system settings. External drives, cloud services, or network-attached storage or NAS can all be used to store these backups. When unanticipated things happen, backups become important because they offer a way to recover lost data, reducing disturbance to your job, personal files, and overall productivity. Since a large portion of our lives are now kept digitally in the age of the internet, losing vital business files, priceless pictures, or significant documents can be disastrous. A strong backup plan guarantees that your data can be recovered in the worst-case scenario. It provides comfort, letting you deal with technological errors without worrying about irreversible data loss, and it speeds up information retrieval so you can quickly get back to your regular routine following an unfavorable event. Moreover, backups are about efficiency and convenience as much as recovery. Scheduled backups on a regular basis make it easier to upgrade systems, migrate data to new devices, and restore a system to a previous state when problems arise. They offer a snapshot of your system taken at various periods in time, giving you the freedom to restore data to the version that best meets your requirements. In a world driven by technology, computer backups provide both protection and flexibility, making them the cornerstone of prudent digital management.